In this section of the training, we'll review the Generation 3 hub bearing. Generation 3 style hub bearings can be either a tapered or ball design. They are a double row bearing design that incorporates a flange for wheel and brake rotor attachment and a second flange for fixing the unit to the suspension. The dynamic load carrying capacity of this bearing assembly is maximized by the use of a separate inner ring for the inboard row. This ring is mounted with an interference fit. The outer ring flange is bolted to the suspension. The rotating inner ring, with its tough flange, spigot or pilot, and threaded holes or studs, is designed for mounting of the brake and wheel. These bearings are greased and sealed, and used for both driven and non-driven wheel applications. For driven wheel applications, torque is transmitted to the inner ring via an included spline. Some Generation 3 hub bearings may also include a wheel speed sensor as part of the ABS, traction control, and/or stability control systems. The sensor can be located between the bearing rows, on the outboard flange, or on the inboard flange. Some sensors are serviceable with a replacement sensor cord, while others are permanently sealed and are not serviceable. In this section, we will only cover a typical front-wheel drive application. The principles are basically the same for all applications of Generation 3 style hub bearings. Tip: Generation 3 hub bearings are precision-engineered components and are susceptible to damage by using an air gun. Do not use an impact wrench when installing these units. Only use the correct axle torque specifications and manufacturer's recommended installation procedure. We'll start by looking at the inspection and diagnosis procedures associated with Generation 3 hub bearings. Begin by following the vehicle manufacturer's recommended procedure to remove the tire and wheel. Remove the brake rotor and caliper or brake drum and then rotate the hub. Any roughness or resistance to rolling is an indication of contaminant intrusion or a failed bearing. If these conditions are present, the bearing requires replacement. Do not attempt to disassemble the bearing for repair. It is not repairable. Tip: on vehicles equipped with disc brakes, remove and hang the caliper out of the way using a wire hanger. Do not support the caliper by letting it hang by the brake hose. On vehicles equipped with wheel speed sensors, disconnect the sensor and hang the sensor wire out of the way using a wire hanger. Next, check the bearing end play using a dial indicator. Mount the dial indicator base on the frame. With the dial plunger or pointer against the flange face, set the indicator gauge at 0. Grasp the hub flange at the 3 o'clock and 9 o'clock positions. With equal pressure on both hands, push straight in and read the dial indicator. Then, with equal pressure on both hands, pull out and read the dial indicator again. The bearing end play is equal to the total dial indicator movement. End play should not exceed 0.003 to 0.005 of an inch. Also, inspect the hub flange for excessive runout. Excessive runout or a bent wheel flange can lead to brake rotor or other component problems in the suspension system. Finally, check the runout by using a dial indicator. Mount the dial indicator base in a non-movable location, such as the frame. With a dial indicator plunger or pointer against the hub flange face, set the indicator gauge at 0. Rotate the hub and read the dial indicator. Runout should not exceed 0.002 of an inch. Now, let's look at the hub bearing removal procedure for Generation 3 hub bearings. Start by disconnecting the wheel speed sensor and remove the electrical connector from the bracket if applicable. Remove the hub bearing retaining nut from the CV axle shaft. Remove the bolts that attach the hub bearing to the knuckle and then remove the hub. Tip: be careful not to damage the CV shaft outer boot. Some applications incorporate a splash shield that attaches between the hub and the knuckle. If present, note and mark the position of the shield on the knuckle for correct reinstallation. With the hub now removed, let's review the steps for installing a Generation 3 hub bearing. Tip: some hub bearings use an O-ring or other form of seal. Inspect and replace as needed. Begin by removing grease, dirt, loose rust, and corrosion from the knuckle. Next, install the hub bearing with the splash shield if applicable on the knuckle, and then install the hub bearing fastener bolts. Torque the hub fastener bolts according to the manufacturer's recommended procedure. Install the hub retaining nut. Tip: some hubs come with a new nut in the box. This is typically when a one-time use self-staking nut secures the hub. In these applications, a new nut must always be used when installing a hub. Reuse of the old nut could potentially cause the nut to loosen during vehicle operation. Next, torque the hub nut according to the manufacturer's recommended procedure. Important: do not use an impact wrench to set the torque of the hub retaining nut. Only use a torque wrench. Reinstall all remaining components per the vehicle manufacturer's recommended procedure. Finally, install the rotor or drum and follow the vehicle manufacturer's recommended procedure to replace the tire and wheel. Tip: the best practice is to have the vehicle on the ground to perform the final torquing to OEM specifications, and always check and adjust the alignment as necessary after this service. Now, let's review some general service information about Generation 3 hub bearings. When installing Generation 3 hub bearings, special mechanical and electrical tools may be required. Generation 3 hub bearings are sealed for life and generally last 100,000 miles. A special vehicle hub nut torque is required when working with Generation 3 hub bearings, and there are specific preload and sensor clearance or location requirements. Finally, do not use an impact wrench to tighten the hub retaining nut. Now, let's review some common causes of failure. Improper hub retaining nut torque can lead to Generation 3 hub failure. Wheel speed sensor failure and seal failure can cause Generation 3 hub bearings to fail. And the failure of other related suspension components can lead to Generation 3 hub failure. Finally, Generation 3 hub bearings can fail due to the use of low-quality or value-grade parts.